Hello and welcome to today's science lesson. So first of all, guys, can we all turn to wave and say a big hello to our friends on camera? Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps, and close our eyes. And when you're ready, guys, you can open your eyes and come back to the room. And next we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then let's go down low. Touch your toes. Back up high one more time. And this time, can we go tippy toe high? While we're there, let's have a wave side to side. And then back down to touch your toes once more. And then stand up and shake it out, guys. Let's have a shake. Arms and legs. Shake it out. Shake it out. And now for some rotations, we'll go left, right, left, right, left, right, left, right, left, right. Excellent, guys. Now, let's take our right hand and find our left foot. Left hand, right foot. Right hand, left foot. Left hand, right foot. Right hand, left foot. And one more time, left hand, right foot. And to finish, we will do 5 claps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So welcome to today's science lesson, where we're going to be continuing about the topic we learned about in the previous lesson. So who can remember, guys, the previous science lesson? What did we learn about? Perfect. Well done. They were the 2 key words from the last lesson. Mass and weight. Okay, so how do we spell mass? M-A-S-S. and weight. W-E-G-H-T. So all together, guys, mass and weight. Now, in the previous lesson, we focused mainly on this word here, mass. Now, can anybody remember, if I say to you, what is mass? Perfect, down. Very well remembered. Mass relates to matter. The amount of matter in an object is the amount of mass it has. So matter is very important in relation to matter. Now, from previous science lessons, how many different types of matter have we learnt about? Perfect. Well done, Pak Bung. Now, who can tell me what were the 3 different types of matter? Liquids 1, L-I-Q-U-I-D. Liquid, gas, and solids. Brilliant, guys. Very well remembered. Liquid, gas, and solid are the 3 different types of matter. The amount of liquid in a bottle, or the amount of gas in a balloon, or the amount of solid, like a pen, means the amount of matter. And the amount of matter relates specifically to mass. For example, I have 1 marker pen here. How many pens can you see? 1. If I produce another marker pen, how many now? So what do you think has more matter? 1 marker pen or 2 marker pens? Yes, well done. The more objects we have, we increase the amount of matter. 1 marker pen, 2 marker pens. 2 is more than 1. So 2 marker pens will have more matter and therefore will also have more mass. And what we're going to do today is we're going to move on and have a look at this word. Now, you may be more familiar with the word weight, because weight is something we use when we want to weigh ourselves. But a question I have for you guys, mass and weight, are they the same? No. Correct. Mass and weight are not the same. How are they different? Any ideas? If I say to you, how are mass and weight different? Anybody have any ideas? You can have a guess because we're going to learn about it in today's lesson. But anyone have a guess? Anyone brave enough to have a guess? Okay, I'll tell you. Mass, the mass of an object always stays the same. But with regards to weight, depending on where we are, weight can change. So we can say here, mass stays the same. Okay? Wherever we are, your mass or the mass of this marker pen stays the same. But if we change places, do you know, sometimes if we change places, weight can change. Now, does anybody have any idea, thinking about planet Earth, what keeps us stuck on planet Earth? Why can our weight change? What is it that makes our weight change? Excellent, Preo. Yes, gravity. Our weight can change depending on gravity. But gravity will not change the mass. Gravity doesn't change mass. Mass always stays the same. But gravity can change the weight. Now, for example, where are we now? What planet? Earth. So this is our weight on planet Earth. What happens if I go into space where there's no gravity? I float. My weight changes. I weigh much less in space because no gravity. That's why when you see pictures of spacemen, astronauts in their suits in space on the moon, they're all floating about. Yes, because they have less weight. And what we're going to do in today's lesson is we're going to look at and try to understand the differences between mass and weight and the effect that gravitational force has as on our changes of weight. But guys, that was brilliant, very well remembered. And what we've got now is a PowerPoint presentation for our students to observe, listen to, and also practice speaking of some of the main ways in which mass and weight are different. And once again, we'll be coming back to gravitational force. So let's all turn to look at the TV screen, guys, for our PowerPoint presentation. So now let's take a look at our PowerPoint presentation, Mass and Weight, Lesson 2. And here in the picture, can anybody guess what they can see? What type of object can we see in the picture we use to weigh things? No, something we use to weigh matter. Scales. Well done, yes. These are scales. And scales are used to measure mass and weight. Different types of scales for different types of objects. This is what's known as a compression scale. Yes, and what compression means is because we have to push down on it. We place the object on the top here, and now however much it weighs, it will move the tray down, and then we will see the weight. The weight of an object measures how much gravitational force is acting on it. Yes. Now what can we see in the picture, guys? Yes. What's the bigger thing in the picture? Tree. Now what's happening to this apple here? It's falling down. But why is it falling down? Why doesn't it float up? When the apple comes off the tree, why doesn't it float up into space? Because gravity is forcing it down. And you can see these apples here have already fallen down. But what is it that makes the gravity work on the object? Weight. The weight of an object determines the amount of gravitational force. If something weighs a lot, it will fall to ground quickly, yes? Like imagine if we had a television and I held it in the air and let go. What would happen to the television? Quickly or slowly? Quickly, because it weighs a lot. But how about a feather? How about if I had a feather and I just held it up and let go? Would the feather fall quickly or slowly? Slowly, because the less weight, the less gravitational force has an effect. A spring balance and a compression balance can be used to measure weight. Okay, so if you have to measure the weight of objects, these are the two things you can use. This is what's known as a spring balance. And do you know why it's called a spring balance? Because it has a spring. What we have to do, you see this hook here? You attach the object you want to weigh, and then the weight of the object will move the hook down because it's on a spring. And then you will see how much the object weighs. So that's how a spring balance operates. This one we've seen earlier, compression balance. And what we do with this one is we put the object in the top, and the weight of the object will push the tray down. And however much the object weighs, you will see on the dial here. So spring balance and compression balance. The more mass an object has, the more weight it has. Yes. For example, how many weights can you see here? 3. 50 milligrams, 1 kilogram, 2 kilograms. Okay, now which one has the most weight? Yes. How do you know? You're right, it's 2 kilograms because it weighs the most. Which one has the least mass? This one, the smaller one. So the biggest mass also has the most weight. The smallest mass has the smallest weight on planet Earth. Therefore, there is also more gravitational force acting upon it. Now, gravitational force we've learnt about already, but it's important in relation to weight and mass, because gravitational force is what keeps weight down near the ground. If we had no gravitational force, it wouldn't matter what we weigh, we'd float up into the air. But because of gravity and gravitational force, it pulls objects down to the ground based on their weight. Our weight on the moon is less compared to our weight on Earth. Yes. You can see the spaceman there. Now, the spaceman has to wear a special suit because one other thing we don't have on the moon, oxygen. So they need a special suit for breathing. Okay? If you just go to the moon, Nadia, in them clothes, you won't live very long because you can't breathe. That's why we need to wear the special suit. And you see here, this is filled with oxygen so that we can breathe. So the question is, why do you weigh less on the moon? And we learned earlier. Can anybody remember? This is because the moon's gravitational force acting on the person is less. Very little gravity on the moon. So there's very little weight. The mass stays the same, but the weight changes. The mass of an object is the same in every place. However, the weight of an object changes from place to place. Okay, now this picture here, what planet can we see? Earth. So the weight of the person on planet Earth is around 560 newtons, because newtons is what's used to measure weight. So on planet Earth, 560 newtons. But the same person, if they go to the moon, see the way their weight changes now? Not 560 newtons, 90, more or less. Less, a lot less. That's why we float up in space, because we weigh a lot less. Why do we weigh a lot less? Gravity. No gravity in space. But mass always stays the same. Our mass on planet Earth, 56 kilograms. And if we go to the moon, our mass on the moon, 56 kilograms. Mass does not change wherever we are. Weight changes based upon the gravitational force. Any questions, guys? Okay, that was brilliant. Very well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation so that they can understand the main differences between mass and weight. And the main difference is the effect that gravitational force has. Because whereas mass will not change wherever we are, the weight of objects, and people too, can change. Which is why we can stand on the ground on planet Earth, but we will float in space. Because in space, a lot less gravity. And now, time for our stretch sequence, guys. So let's stand up and push in our chairs. And for this sequence, we can have a game of Teacher Says. So listen carefully. Teacher says, hands on hips. Teacher says, stand on one leg. Teacher says, arms in the air. Teacher says, swap legs. Jogging on the spot. Teacher says, jogging on the spot. Teacher says, jogging on the spot with both legs. You can use both. And teacher says, arms side to side. And teacher says, arms backwards and forwards. Stop. Teacher says, stop, and stand straight. Teacher says, arms by sides. Teacher says, turn around. Teacher says, back the other way. And back the other way. Teacher says, arms by sides. And teacher says, into a little ball. 5, 4, 3, 2, 1. Jump. Teacher says, jump. And teacher says, please sit down. And teacher says, it's now time for our flashcard part of the lesson, where we're going to have our students work in pairs or teams of 3 to put sentences together and speak them correctly. So teachers, what you'll need to do is print off 2 sets of flashcards. The first set we're going to place on the board here and have our students practice speaking. But the second flashcards cut all the words into individual cards. And then, when we give each team a set of cards that make up a sentence, they have to form them together and then practice speaking. So first of all, the first set to practice speaking, guys. The weight of an object measures how much gravitational force is acting on it. Yes, the more something weighs, the more gravitational force there is. A spring balance and a compression balance can be used to measure weight. So remember the picture from the flashcard. The spring balance will pull it down. The compression balance, we put plates on the top. The next sentence you might get, our weight on the moon is less compared to our weight on planet Earth. Yes, that's why we can stand here on planet Earth, but we cannot do this on the moon. If we were on the moon having this lesson, we would all be floating in the air. The more matter an object has, the more mass and weight it will also have. So the more matter inside an object means more mass and more weight. And the final sentence that you might get, so pay attention. We weigh more on planet Earth because gravity is pulling us to the Earth's center. Yes, always to the center of the Earth. Now we have our 5 sentences. What we need now are our teams. So Bangpon and let go, team 1. Prel and down, team number 2. Chu and Nadia, team 3. And Pat, Pakbung and Net, team number 4. So we're going to give each team one of the sentences on the board, but all the words are jumbled up. They need to form the sentences together and then speak that sentence correctly. And then when everybody's done, we can change the sentences around. So first of all, team 1 and team 2. Team 1. But not yet, wait till everybody's ready. Team 2. You're welcome. And now for team 3 and team 4. Okay, so now you all have your sentences. Your sentence you have to put together is on the board. Team 1, ready?
Ready.
Team 2, ready? Team 3, ready? Team 4, ready?
Ready.
3, 2, 1, go. Okay, so find your first words, guys. The weight of an object, that's correct, Pak Bung. The more weight. Our weight on the moon is less compared to. Okay. Our weight on the moon is less compared to weight on planet Earth. Excellent, guys. The weight of an object measures how much gravitational force is acting on it. Brilliant, guys. Very well done. The more matter an object has, the more mass and weight it will also have. Excellent, Pangpon and Lakgao. Well done. Team 3. Let's see, what do we have? Perfect. Well done. We weigh more on planet Earth because gravity is pulling us to the Earth's center. Excellent, Nadia. Very well done. And well done, Chu. Okay, guys, that was brilliant. So now take the cards and pass them to the teams on your left. Net, I'll take your ones and pass them to team 1, Lakgao and Bangpon. So teachers, what you can do now is you can see the activity that we're doing in our classroom. You can pause the video and do the same activity with your own students. And remember, after each round, to swap the sentences. That way, all the students get to practice speaking and forming the different sentences. So team 4, are you ready? Team 3, ready? Team 2, ready? Team 1, ready?
Ready.
Okay, 3, 2, 1, go. Okay. The weight of an object measures how much gravitational force
Four.
is acting
Acting
on it.
on it.
Brilliant, guys. Well done.
The
More matter an object has, the more mass and weight it will also have. Perfect. Well done, guys. Our weight on the moon is less compared to weight on planet Earth. Brilliant. Well done, guys. And team 4 weigh more on planet Earth because gravity is pulling us to the Earth's center. Brilliant. High five and well done, guys. Once again, let's get our cards, pass them to the teams on our left. So I'll take these and pass them to Latgao and Bangkok. So ready for the next round? Team 1, ready?
Ready.
Team 2, ready? Team 3, ready? Team 4, go. So have a look at your sentences, guys, and put the words together. We weigh more on. Not correct. Not right. The weight of an object measures how much gravitational force acting on it. Well done, guys. Our weight on the moon is less compared to weight on planet Earth. Excellent and well done, guys. The more matter an object has, the more mass and weight it will also have. Excellent, guys. Very well done. And now, team 1, ready? We weigh more on planet Earth because gravity is pulling us to the Earth's center. Excellent, guys. Well done. Okay, now it's time for our final round. So let's pass the cards to the teams on our left one more time. So Pak Bung, I'll take your cards and pass them to Bangpon and Latgao. So one more round, guys. Let's see who can get this one. Team 3, ready? Team 2, ready? Team 1, ready? Team 4, ready? 3, 2, 1, go! Final round. And remember, guys, take your time. Better to be correct than be quick. Our weight on the moon is less compared to our weight on planet Earth. Excellent, guys. Well done. Way more on planet Earth because gravity is pulling us to the Earth's center. Brilliant, guys. Well done. The weight of an object measures how much gravitational force is acting on it. Excellent. Very well done, guys. And team 4, the more matter an object has, the more mass and weight it will also have. Brilliant. Well done, guys. Guys, that was excellent. Give yourselves all a big round of applause. And now it's time for our worksheet part of the lesson. So teachers, make sure all of the students in your class get their own worksheet. And what they need to do is they need to think about what we've learned in the previous few lessons about mass and gravity, because we have 8 sentences with 8 missing words. Now the missing words are contained in the word box, but our students need to read the sentences and decide which word fits best. What's the first thing to do, guys? Names on top first. Give our students around 10 to 12 minutes for the activity and just help them with anything they need. So Bangpon, this one's for you. Bakau, for you. You're welcome. Prau, this one's for you. You're welcome. And down for you. Chu, this one's yours. You're welcome. Nadia, for you. You're welcome. Pat, this one's for you. You're welcome. Pak Bung, you're welcome. And Net, you're welcome. So guys, names on top first of all, then have a read of the sentences and try to remember which word fits best. But I'll give you a word of warning. It's not the same sentences on the board. So you have
the earth is what pull everything to
center. Perfect. Well done. So number 1, the gravitational force. And what you can do then, Prau, once you've used it, cross it out, because you only need one word. Okay? Without gravitational force, everything will leave the ground and float. Yes, if you see something in the air, floating, that's what we would do without gravity. So remember, what did we talk about when we talk about matter? What does matter equal? Now be careful, is it weight or mass? Remember, the amount of matter in an object is mass. It can also increase the weight, but mass and matter are directly connected. So number 3, the mass of an object is the quantity of matter in it. Mass and matter are directly related. The mass of an object affects its... Let's have a look. Affects its... motion. The motion. Remember back to the last lesson when we had the shopping trolley. The empty shopping trolley was easy to move. The full shopping trolley, hard to move.
The gravitational force on it.
That's perfect, Claire. Excellent. The weight of an object. Now, what type of balances did we learn about?
Spring balance.
A spring balance. Well done. The spring balance is the one where we pull from the bottom. The other one, the compression balance, we weigh from the top. Now think about it. Does the weight change? What did we say about weight? Does weight change if we weigh something on Earth? Remember what we said about planet Earth and the moon? Do we weigh the same on the weight? The weight changes, but the mass stays the same. Oh, excuse me. The weight changes, but the mass stays the same. So number 7, the weight of an object changes from place to place. That's why we weigh something here on Earth, but we weigh less on the moon. But the mass of objects stay the same. And don't forget your name. Welcome back to class. We hope your students enjoyed the exercise with the worksheet where they had to change all of the different sentences with the complete words. And each word only needs to be used once. So once we've used it, guys, you can rub it out. And my students here all did a brilliant job. So big round of applause for you guys. And that's all we've got time for today. So we hope you've enjoyed the lesson and now understand more about the differences between mass and weight. Mass is directly related to the amount of matter in an object and stays the same everywhere. Weight can change from place to place depending on gravitational force. And we'll see you again soon for the next lesson. So can we turn to wave and say goodbye, guys? Bye-bye. See you again soon.